Hello everyone, hope you are all doing fine. Today I will explain for you the part 2 for the modes for heat transfer. The first part was the plane wall, the second part is the cylinder wall. So if we go to the cylinder wall, it is a very easy. We know that we have the Q, this is the Q for heat transfer, and we have the area and the delta T, right? And down it will be the length. So this is 2 pi k L delta T, this is for the area, and K for the coefficient for heat transfer, and delta T for heat transfer. And down it will be len, you know the len in the calculator, len RO, it means the radius for the outer radius, and RI for the inner radius. So then if we make some substitution due to Ohm's law, we will find that the Q equal delta T over len RO اللي هو R radius outer for inner radius over 2KL. I can write it to you here. It is Q over delta T over what? Len RO over RI divided by 2 by KL. Okay? Delta T is for the temperature difference. This is for the outer radius. This is for the inner radius. K, it is for the coefficient for heat transfer for the material. L is the pipe or the cylinder length. Okay? And for R is the resistance. The resistance, as we said, would be len RO over RI divided by 2 by KL. This is in case for the first one, the conduction. If we move to the convection, the convection rule is Q, the H, A, delta T. A is the area, right? And here Q, it will be the same, Q delta T over 1 over HA. R equal 1 over HA. The area here is by DL. D here is for the diameter. D here is for the diameter. Okay? If you can see this is an explanation. So we can take an easy example. This is a toys for the kids. For example, this is the green one is R. Let's write it here. For the green, it will be R inside. So this will be R inside R1. For example, and the second R, it will be the orange one, and this orange, it will be R2, and the fade green or light green, it will be R3. Okay, so here we have 3 cylinders through each other, okay, with length L. So the length will be L. We have R and the length. And what about the K? This is K1, K2, K3, K1, K2, K3. Okay, in life, what will be this? Maybe this is a pipe, there is a water goes here, and there is another water goes here for cooling, or maybe this is for heat transfer. They want to transfer this to outer thing. So in this case, it will be like this: conduction, conduction, conduction. And so it will be R1, R2, R3. They are all conduction, right? And they are all in series. So maybe you will find something else. Maybe in the problem he will tell you there is something put between R1 and R2, like this. There is an insulation added between R1 and R2, like this. So you will have R1, R2, R3, and you will have insulation, or it's not maybe insulation, any other material added between R1 and R2. R1 and R2, there is something added here, right? This one, okay? For example, if this one, for example, is plastic, so this it will be what? It will be conduction, right? Yeah, so there will be here, this will be conduction, and here, it will be, convection, and will be here conduction, and here conduction, right? As we said before, that the plastic is what? Is a convection, it's not conduction. Do you remember in sheet 1? So this is to understand if there is only pipe, or there is something added between the pipes, okay? If something added between the pipes, there will be convection. If nothing, it will be all conduction, okay? Conduction, if nothing added. R1, R2, R3, extra. In case of convection, if there is something added between R1 and R2, or R2 and R3, etc. Okay? It's very easy. The sheet will be on the next link. Explanation for the equation.